Hello, and a very warm welcome to the theIAShub. My name is Madhusudan Reddy, and today we are on the 10th session of the Basics of Geography, where we will be discussing the subjects of geography in a very lucid and simplified manner. The topic for today's discussion is waves. Last class we have discussed about tides, so here we are yet to discuss the concept of waves. And before we start with the session, the optional geography is going to start soon. You can get enrolled into this optional subject, and the details are given here. And for further details, you can also contact the numbers which are given onto the screen as well. And as usual, if you do have any doubts, you can ask me into the comment section. Online students, I'll be addressing them in a detailed manner. Right? So let's quickly move ahead with the concept of tides today. So our concept of today is to deal with the waves. So last class हमने tides के बारे में discuss किया. We got to learn about what are the different types of tides and at what time period you will get to see the tides, right? So today we will be discussing in detail about the waves. So to understand the concept of the wave, firstly you need to understand what are the type of waves that are there, right? In optional, generally you will study little more in detail about the types of waves. So today our agenda is to get that basic understanding, ये waves कैसे बनता है, or ये waves, how exactly they are formed, and what are the factors that determine the formation of the wave as well, right? And if you do have any doubts regarding the last class concepts also, you can post it into the comment section. I'll be addressing them as well, right? Now let's start with the concept of waves. I hope, how many of you have visited a beach? Visit kiya? No. So many a times I tell my students that I come from a city which is next to the beach, that is Visakhapatnam. I've done my graduation in that city. So beach is very, not from our college, it is hardly 100 to 200 meters away from the beach. So we used to see different types of waves in that beach. So let me show you. If you look into the waves, waves are not just part of the ocean. These waves are also present in the lakes as well. You'll also find these waves in the air. If I'm speaking, if you are able to hear, it is because I am sending a sound wave. I've created a sound wave, and that sound wave you guys are able to hear. That is the reason why you are able to hear, right? Now here, firstly, you need to understand the concept of wave. Wave is not just the movement of water. It is not how the water moves. It is about how the energy transfers from one place to another place. Usually, the movement of water takes place. There's no doubt in the wave, but to what extent or what distance the wave displaces the water is something which we need to ask for ourselves. See, there are different types of waves. There can be a wave which is called as siege wave. There can be a gravitational wave. There can be a wave that can be longshore. There can be capillary waves. There can be gravity waves. Alag-alag types ka hota hai. So, firstly, we have to understand wave exactly kya hai and how the formation of the wave takes place. So let's quickly get into this. So how do you define a wave? Can anyone define me? What exactly is a wave? Online? So Chahat here says that transfer of energy from one place to another place. No doubt, yes, if this is your point A and this is point B, the transfer of energy from place A to B, this is called as wave, right? This transfer of energy can be taking place in the air. It can be taking place in the clouds also. This transfer of energy can also take place within the water as well, right? So those energies that are transferred from one place to another place within the water, okay? Imagine this is your water, and from in this due process, you got to see that the wave has transferred the energy from place A to place B, right? It is not the displacement of water from place A to place B. Yesterday last class we have studied that if this displacement takes place, what is it called? It is current, right? So broadly speaking, this is nothing but your wave, right? Now this waves has propagations. You need to understand the concept of propagation and propagation of the wave, or the particles which propagate in the wave while the wave transfers from one place to another place. So if you understand the concept of the transfer of propagation or the movement of propagation of the particles and the direction in which the wave travels or the direction in which the wave movement takes place, then the concept of waves is an easy peasy topic, right? Most of the students, they do not understand exactly propagation kya hota hai and particle propagations, is it longitudinal, is it transverse, now is it parallel, perpendicular, इनमें काफी सारे doubts हैं. So first we will try to understand the concept of propagation of particles in a wave, and then we'll come to the types of waves later, right? So I have Sagnik Das here also, right? So firstly, there can be two different types of waves. First one, it is longitudinal wave. Second one, it is transverse wave. In the longitudinal waves, if suppose, imagine the wave is traveling in this direction from point A to point B, the particles will also travel in the same direction, right? Now simply, for suppose, imagine that you have a piece of rock or a piece of material, and in this piece of material, you get to see multiple particles present, right? ये सब particles है. And these particles are tightly packed. These particles are tightly packed in a solid, but these particles can be loosely packed in a water, right? So imagine that this is your water and this is your solid. Suppose when a wave travels from point A to point B, okay, again let's call this as point A and let's call this as point B. In this, the energy transfers from A to B. Now while the energy that is being transferred from point A to point B, you will get to know that here, imagine this is how the direction of the wave traveling. That means the direction of the wave is also moving in this direction. If suppose this particle, imagine you have this particle which is present in the rock or the solid, if this particle also moves in the same direction, right? If this particle is also moving in the same direction, then this is called as a longitudinal wave, right? So ये है longitudinal wave. Now these longitudinal waves are, if I am speaking sound wave is also a longitudinal wave, right? So in this due process, the propagation of the particles is parallel to the direction of the wave. Is it right? Clear? The wave is also traveling from A to B in the same direction, and you got to see these particles can either move forward and backward. This particle, it can move until here and again it can come back. So in this due process, the particles are also moving in the same direction and the wave is also moving in the same direction. When these two are in parallel, this is nothing but the propagation of the particles is in parallel to the direction of the wave. So this is called a longitudinal wave, and this longitudinal wave is nothing but a sound wave as well. Now coming to the same concept into the water, right? So suppose, imagine from this point, you got to see the energy from point A is now being able to transfer to the energy to the point B. In this due process, you got to see the transfer of the wave, which is moving in this direction. But imagine there can be water which can move in the same direction, right? Water can move in the same direction. If that water is moving in the same direction, this movement of the wave is in longitudinal wave. ठीक है? ये एक longitudinal wave बन सकता है. Now let's try to go to the second condition. The second condition is the second type of wave which you will have is called as transverse wave, right? You have a transverse wave. If you remember in the second class, we have learnt about the interior of the earth. in the interior of the earth, we have also understood the same concept, but we have applied it with the seismic waves. Okay. Today, what we are doing, we are applying the same concept of waves to the oceanic movement of water, which are getting displaced, right? Look, here you will get to understand that in the transverse wave, see, how does the transverse wave movement takes place? Imagine, let's take the same example and try to understand it. Again, you have a piece of solid materials. This is a block of solid. And you have all the molecules present here are tightly packed. Right? Now let's try to pass a wave which is a transverse wave. Let's try to understand a transverse wave. From point A to point B, if it is traveling, this is how the movement of the wave takes place. In this transverse movement of the wave, you will understand that while the wave is traveling in the same direction, in the previous case also we have seen that wave A se lekar B tak ja raha hai, but here you will see that the particles are not moving in the same direction as the wave is traveling. You will see that the particles will move not in the direction. Imagine, let's go to these particles. Imagine this is your small particle. And how does the particle move? It will not move in the same direction. It actually moves up, and this particle may do down. Right? So look here. If I have to exaggerate this, diagram, this is moving in this direction. Maybe this particle might move in this direction. Right? Wave ka direction kya hai? A to B. But is it perpendicular to the direction of the wave? The propagation of the particles, that means how the movement of the particles are taking place. It is perpendicular to the direction of the propagation of the wave. That means this angle jo hai 90 degrees hai. Right? Ye jo angle hai 90 degrees. And this kind of wave is called as transverse wave. Right? So waves दो तरह आपको समझ में आ गया. एक तो longitudinal wave होता है. Longitudinal wave में the wave propagation is parallel to the direction of the wave. Transverse wave mein you got to see that the direction of the wave and the propagation of the particles are perpendicular to each other. Now what kind of wave is your oceanic wave? My question here is, what kind of wave is your oceanic wave? Yes? Is it a transverse wave or is it a longitudinal wave? Yes, we are studying about the oceanic wave, right? So you tell me, I have told you the types of waves. Can you tell me what kind of wave is an oceanic wave? Is it a transverse wave or is it a longitudinal wave? I'll be waiting for 10 seconds online. You can answer as well. Chahat here says that transverse. Okay, Chahat ka example ye hai, when he throws some stone, he says that the water goes in circular motion, right? This is what you wanted to convey. So let's see, the wave can be of different types. A ki jagah you will get to see multiple waves. This is your capillary waves, this is your gravity waves. So look, there can be different types of waves. So your explanation is that when you throw the stone, the water will start to ripple around, right? So what is that movement? You're coming up with an explanation. Transfer हो रहा है, तो transverse wave है. Wave. The water is going up and down, so you call it as transverse. But don't you think that there is a displacement of water also in the wave? So Suman Kumar says longitudinal. Only Suman Kumar answered. Sagnik says longitudinal wave. If you are telling me a longitudinal, give me a logic. If you tell me it's and transverse, you give me a logic. Longitude में displacement of water होता है. फिर transverse, चाहत तो कह रहा है transverse है. चलो मैं समझाता हूँ. It is actually, in a wave, you will have both. In the oceanic wave, you will have both longitudinal plus transverse movement of water, or else transverse movement of the propagation. That is the reason why your wave makes a circular motion. Okay, your wave, while it is traveling from one place to another place, the energy while it is traveling, the water makes a circular motion. Right? Let's try to understand this. For example, you have this water. I told you that there are both the conditions you will get to see. Right? Imagine this is your ocean. Right? ये आपका ocean है, and in this ocean, suppose this is A and this is B. Right? From here, what you have done is you might have thrown a stone at A, then the wave will start to move. Along with that, it will displace the water. Displacement of the water, it doesn't mean that the entire water from here it will be carried to B. No, it's not like that. If that is traveled, it will be a current. Okay. Now, here, imagine that you have generated a wave. Right? In this generation of the wave, it is actually not the movement of water transfer. Remember this very carefully. In this, you get to see the water moving in this direction. So what will be, if the movement of the water is in the same direction, is it a transverse wave or is it a longitudinal wave? It's longitudinal, क्योंकि parallel है, right? तो आपको ये समझ में आया, this is nothing but a longitudinal wave. But you will also have the transverse motion of the water, right? You will have a longitudinal wave, you will have a transverse motion, again you will have longitudinal, and again you will have transverse. This is how the movement of water takes place. Now your oceanic wave is a combination of longitudinal plus transverse. Like this, once the water makes a circulation, it will start to transfer its energy. So again, you will have a longitudinal wave, longitudinal motion, and then you will have a transverse motion. Right? Like this, your movement of the ocean water, it keeps on making a circular movement. Water हमेशा circular, यहाँ से यहाँ तक ही होता है. It is not the energy. Once the water makes a circulation, the energy is transferred, the energy is transferred, the energy is transferred. Like that, the energy is always transferred, right? Now, you have to understand what are the causes of the formation of this wave. You tell me, what are the factors which lead to the formation of the wave? What factors? Right? So, let us try to understand the factors that will cause the formation of these waves. First one, these factors or forces can be divided into two types. One, which are producing waves, one which are producing factors, and the other one, restricting factors. Producing factors में, that is producing forces, or factors. First one, it is your wind. Next, what else can be there? What else can be the factors for the production of the waves in the oceans? It is catastrophic waves, that is catastrophic forces. Next, gravity. Is gravity a productional force? How is gravity acting as a force to create waves? Transverse wave is fine, but I'm talking about the producing forces. See, क्योंकि वो सेंटर की तरफ अट्रैक्ट करता है. देखो, you have to understand the concept of hydraulic gradient here. Hydraulic gradient मतलब, suppose there can be on the part of the earth, there can be oceans which are present, which are the height of the ocean can be more, and at places the height of the ocean can be less. See, in the optional you will understand that actually the height of the ocean will be more at 30 degrees. at 30 degrees latitude, you will have the height of the ocean will be more. And also at the equator as well, you will have slight increase in the height of the ocean. Why do you have an increase in the oceanic height in the equator and at 30 degrees latitude? So चाहत का कहना ये है यहाँ पे evaporation है, precipitation यहाँ थोड़ी हो रहा है. At the equator, imagine this is at equator. If you give me the logic that sir evaporation ज़्यादा है, temperature ज़्यादा है, तो I do agree. At the equator, you will learn that your NCERT also says that near about 6 to 8 centimeters of the oceanic height जो है, it is more, right? Why? At the equator, on an average, the annual temperature which is there, it is nearly more, right? But why is at 30 degrees latitude, you will find the height of the ocean to be little high? See, if you understand this, the concept of the waves topic will be little more easier. Now let's come back. First one, you need to understand that this is your equator and this is your 30 degrees, right? And at the equator, the temperatures are high all throughout the year. Now you take a bowl of water and you start to heat it. What happens? The water will start to expand. And that's the reason why you will understand that at the equator, the oceanic height jo hoga, it is usually little swelled. The ocean is swelled. And the other reason, if you look into, is that temperature high hai. यहाँ पे आपकी temperature high होने के कारण the height of the ocean is less. Now as you go towards the 30 degrees latitude, in between, you will find that the depth of the ocean, or the oceanic height jo hoga, it is little lowered. Why? Because temperatures will get reduced, but again, at the 30 degrees latitude, piling up of water takes place. Why is that piling up of water? Why piling? Look, piling is associated with the concept of, if you have studied the oceanic currents, in the oceanic currents, I have explained you, in the Atlantic Ocean, there is gyre circulation that is forming, right? Gyre circulation क्यों? See, you have to understand multiple concepts, only then this oceanic wave concept will be very, very easy. So, ये है आपका equator. From 5 degrees north, the wind starts to move in this direction. So, these are your easterlies belt. Right? ये आपका easterlies belt हो गया. And as the wind starts to move in the same direction, the oceanic currents will also start to move. The waves will also start to move. Right? Firstly, the first factor that we need to understand it is wind. Wind is the factor which is causing the movement of the oceanic waves. And wind is also the factor why your oceanic currents are also present. Make this very clear, the difference between currents and the waves. Currents is the movement of the water. Waves is the movement of energy. The energy is being transferred from one place to another place. Here, the energy also started to move, the currents also, the water also started to move. Like this, it will follow the path of the coastline, and it also has the Coriolis force. Coriolis force in the northern hemisphere is towards right. So in this due process, once it enters into the westerlies belt, what happens to the water? Here at 30 degrees latitude, what do you find? You have westerlies. Under the influence of the westerlies, the same water will start to move in a different direction, and it makes a circle. And these are nothing but gyre circulations, right? And here, the water in the westerlies, you also get to see that all the water is getting piled here, right? Piling up of water is taking place. So when piling up of the water takes place, the height of the ocean will also be little more. Got it? So this is your Gulf Stream. In this Gulf Stream, the piling up of water is taking place. यहाँ पे piling हो रहा है. Imagine you take a bucket of water and you throw it onto the floor, right? Wherever the water piles up, the height of the water height is little high. Now, once the ocean is having higher height at one latitude, and at a different latitude, you have little low oceanic height. Again, at the equator, you have this gradient of hydraulic gradient कहाँ जाता है? And this hydraulic gradient will also lead to the formations of oceanic waves. That is also one of the factor. And here gravity factor will also play. It is like this. See, imagine that this is your earth, ठीक है? Now let's try to understand the depth of the height of the oceans. So see, this is your equator, right? And here somewhere around you'll have mid latitudes, right? Let me keep this properly. Yes, ये आपका equator हो गया, and then this is your 30 degrees latitude. In between you got to see the currents which are moving in this direction and they start to pile up here, ठीक है? This is how the piling takes place. At the 30 degrees, because of piling, the height of the ocean is more, and then it will reduce again. It is 8 centimeters more, right? 8 centimeters more. So like this, it is at a, if I draw the same thing in a horizontal profile, it will be like this. ये हो गया आपका 30 degrees. Again, mid latitude, the lower latitudes, this is 0 degree latitude, equator, right? 0 to 5 degrees की latitude पे ये. So if there is a water that is present here, couldn't it be moving in this direction? You throw something there under the influence of gravity. This is hydraulic gradient. There's a slope. That slope will also lead to the formations of waves. So wave formation is a natural phenomena. It is a very, very natural phenomena. And also rotation of the earth is also there. So wave formations naturally hota hi hai. And coming back, wind is the primary factor, right? Wind ke saath gravity also plays a role. And then you got to learn hydraulic gradient also plays a role. In this due process, it is actually 3 producing forces hota hai, right? There are 3 producing forces. Now, what are the forces that will restrict the formation of a wave? What are the forces that will restrict the formation of wave? Surface tension and capillary action. What is surface tension? Anyone? What is surface tension? Friction. Very good. So let's come back. So you got to see 3 producing forces. Now let's try to learn 3, the resisting forces. See, this classroom's ultimate agenda is to give you a lucid understanding. ठीक है? यहाँ पे concept समझो. Do not go behind the terminology. In the later classes, you will get to understand the terminology. So resisting forces में, what is the first resistance force? It is the surface tension. ठीक है? It is either surface tension and capillary action. ठीक है? Can anyone tell me what is capillary action? Capillary action क्या होता है? Online, right? Capillary action. See, capillary action will come back little later. So gravity, no doubt, and here gravity also plays a role in restricting as well. This is because of so the concept of gravity we will study in detail in the advanced class only, क्योंकि यहाँ पे थोड़ा और explanation की ज़रूरत है, right? Because in the waves we will learn what are the different types of waves, capillary waves, swash wave क्या होता है, और rip waves क्या होता है. So that is what something which we have to study. But before that, let's go back to the waves concept itself. Now, are you clear with the wind? You are clear with that. Surface tension is nothing but there is a friction that will be generated. ठीक है? वो जो friction create होने के कारण waves will generally try to restrict themselves. Broadly speaking, while you wanted to move the water on the ground, after some time the water will stop moving. You take a mug of water and throw it onto the ground. After some time the water will start stopping movement. Why? क्योंकि उसके अंदर surface tension भी होता है. So these things will come later. Now the next factor that you need to know is catastrophic catastrophic wind or the catastrophic forces like tsunami, it will also create a wave. Earthquakes will also create a wave. And also landslides. Imagine there is a big mountain and this big mountain falls into the water. What happens? It will also create glaciers. They can break away and they can fall back into the water. It will create a set of waves. So catastrophic events can also create waves, and catastrophically anthropogenic activities can also create waves. So these are some of the forces that you need to know. But more specifically, you have to concentrate on few things in the concept of waves. If you are preparing for the preliminary point of view examination, so you should know here. When does a wave breaks? When does the wave breaks? When does a wave breaks? Suppose, imagine that ये है आपका coastline, ठीक है? This is your coastline, right? And you have this is your water, right? And you got to see the movement of the wave. Imagine the wave is generated somewhere here. It starts to move in this direction, but when does exactly the wave stops or formation? जब एनर्जी खत्म होगा. वेव का एनर्जी कहां पे खत्म होता है फिर? Where does the energy of the wave can be finished? Particles. Particles का propagation बंद होगा तो wave का energy बंद होगा. It's not like that. See, आज ये मान के चलो, I told you wave is nothing but the transfer of energy. Don't you think that the energy is naturally generated in the oceans and that energy is coming onto the shores? Can't you capture that energy? You can, but आज की technology costly है. वो जो technology to capture the energy that is generated by waves, the technological advancement is not up to the mark. There are few countries which are actually trying to capture this. ठीक है? This is nothing but wave energy capturing technology. अभी 4 दिन पहले you got to see in the current affairs, the Norway is working on this, and also Canada is also working on this technology. Come back. You need to understand firstly few things. Basics पे चलते. Let's go to the class 6 or class 7 understanding and try to understand what exactly is wave, wavelength क्या होता है, crust क्या है, trough क्या है. See, the lower part of the wave is called as trough, and this is called as crest. And what is the wave height? Wave height क्या होता है? Wave length is this, ठीक है? From crest to crest, this is nothing but wave length. This is wave length. Wave height क्या है? Wave height is if this is the sea level. No, frequency is different word. If suppose this is the level of sea, and this will be your wave height. Right? This is your wave height. Frequency is the highest point and the lowest point. That is frequency. Right? Wave height is the mean sea level से at what height the wave went. That is your wave height. Now, ये है terminologies. Look, in this due process, what do you get to see is that if suppose here the wavelength of this wave is 3 meters, ये मान के चलो, ठीक है? So in this 3 meters, you get to see every wave there is a horizontal movement and there is a vertical movement, right? In this due process, the longitudinal movement is also there, transverse movement of water is also there. That's why it is making a circle. And here also the water moves in circular motion. Here also the water moves into the circular motion, right? So always the water moves in circular motion. The maximum displacement of the water you will get to see is in the longest waves, that too hardly 100 से लेकर 300 meters की बड़े wave होता ही नहीं है, ठीक है? That is the maximum displacement of the water you will get to see. Usually 1.6 से लेकर 3 to 4 meters की बीच में the water keeps on circulating there. It is the same water which keeps on circulating within 3 to 4 meters of distance itself. So it feels like the water coming up and going down, it's because of tides. But waves, it only makes a circulation, right? Now, if the wavelength is about 3 meters, ye maan ke chalo, if suppose the depth of the ocean is 50% of the wavelength of the ocean, then your oceanic wave, the oceanic wave breaks. Let me repeat. ये wavelength क्या है? 3 meters. लेकिन this is your coastline, right? ये है आपका coastline. And on the coastline, you might be having some coconut trees. So here, if the depth of the ocean is 50% of the wavelength of the wave, then only your wave breaks. Got it? मतलब अगर depth 1.5 meters से कम है, this wave will break. How does this wave breaking happens, and why does the water comes into the coastline and then recedes back? This is also you need to know in this. So here, let's try to understand the concept of the swash or the movement of wave into the water, right? So for this, let us try to break the wave into two different types. So ये है आपका water, right? There is a wave that is moving ahead, and then you got to see the circular motion of water, right? Clear? Now what I'll do is, to explain it, I'll be breaking the wave into two different halves. Now this is your frontal portion, and this is your rear portion of the wave, right? In the frontal portion of the wave and the rear portion of the wave, you need to understand here what kind of movement you see. You see the longitudinal. Here mostly it is transverse, like this. Now the wave is moving from A towards B. Let's see if the depth of the oceanic water is less than the 50% of the oceanic wavelength. What happens? Imagine that you have a coastline. ठीक है? This is your coastline, and so ये मान के चलो, this is the depth of the coastline, and these are all your water. So look at, this is the frontal portion, this is the rear portion of the wave. In this frontal and rear portion, the rear portion is moving, is dominated by the upward movement. ठीक है? The frontal portion is dominated by backward movement, right? Look, every time the wave moves forward, what do you get to see? The water rises and then the wave moves forward. If the wave wants to go back, the water sinks and then they move backward, right? Motion of the water beneath the ocean is, if the water wants to move forward, it will rise and then move forward. If they want to go back, they sink and then they go back, right? So look, if the wave length, if the depth of the ocean is 50% of the wavelength, you will get to see that the chances of a circular motion of the wave is very less. So this is the movement of the wave or the movement of the water. And next, here, when the wave breaks, it is actually, this is the rear portion, but the frontal portion, they'll start to inundate into the coastline, right? This is how you get to see the inundation of the water entering in. After that, once the water went into the coastlines, right? So what is dominating here? You got to see the rise of the water. Again, they have to go back. Circular motion में होता है ना? That is the reason why the water goes ahead and then it has to make a circular motion. As if a person is standing here, it seems like the water comes in, but with the same force, the water will also drag them back. Got it? In the wave, anytime if the water has to move ahead, they move up and the forward. Okay? If they have to go back, they sink and they go back. So that's why while you're going back, you're always advised to be more, you should be united. You are generally asked when you are standing onto the waves, always ek dusre ko pakdo. Ye kabhi suna hoga. Recently, I have visited one of the blue flag beaches. There, the announcements will be there. Suppose they also tell you the high tide time period, low tide time period, and they will also advise that if you're a group of people, what you have to do is should always be together. Okay? The energy of individuals while they catch at one particular place, they will be having more energy. It's like that. So small things maybe that might be helpful. But holistically, agar dekha gaya, it is the same energy that comes in and the same energy that goes back. Right? In this due process, the energy is coming in and the energy also goes back. Now this is the story of your oceanic wave. Right? There is forward movement, there is backward movement. While it is coming forward, it goes up and then comes forward. If it is going backward, it sinks and then goes backward. Right? That's why wave always has a circular motion, because it is both transverse and longitudinal. ठीक है, दोनों waves होता है. If I am speaking, this is sound wave. Sound wave में only longitudinal waves are there. Right? In the light, you generally have transverse. This is how it is. Clear? Now there can be different types of waves. Okay, one of the example of a different type of a wave is siege wave. Okay, kabhi suna hai? Siege waves. Do you see waves in the Sukna lake? Have you ever been to the lake in your city? So this is Chandigarh. Chandigarh, there is a Sukna lake. Kabhi dekha Sukna lake mein waves hai? Never seen. There will be waves in the lakes as well. Okay, do you see tides? Tides can't be formed in a small area, right? Waves, definitely there will be there in every area of a lake. Now, they can be generated by different reasons. Okay, I won't be going into detail, but one example that you need to understand is the siege wave. See, for example, you have a lake. Okay, lake is nothing but, imagine, ये आपका lake हो गया. This is the water. Now, wind plays a very vital role in the movement of a wave. Suppose, if the direction of the wind is uniform, okay, the wave will also be uniform, right? But if there is direction of the wave, local winds here, irregular movement of the wind, what happens to the waves? The waves will also be irregular. So usually in a small area, like Mediterranean Sea देखो या कहीं और छोटे-छोटे areas में देखो, the wind is always in a uniform direction, right? So the wave, what does it do is, it starts to travel and then it hits the coastline. Again, they start to move backward. The energy always goes from A and then they go to B, and from B, they travel back. This is nothing but siege. ठीक है, siege wave कहा जाता है. Usually in a enclosed lakes and all, you will get to see siege, S-E-I-C-H-E. They go back and forth. ये है siege wave. You will also have gravity waves. You will also have capillary waves. You will also have rip waves. ठीक है, ये कुछ ऐसी types of waves है, आपको आगे पढ़ना चाहिए. Now here, let me show you. Sometimes you will be asked not to get into the ocean whenever you have a rip wave. Look, in the rip waves, if suppose if you are struck in the rip waves, it is highly likely that you will not be coming out of that waves. The name in the wave itself says that rest in peace. That is why it is rip wave. Jokes apart, see, usually the water tends to move across the coastlines, and then they combine and collect at one single point, and they tend to move backward. Okay. In this due process, imagine that there is a person who got struck here. Okay. Let's consider there is a person who got struck here. He'll be trying to move against the wave. Okay. He'll be trying to move against the wave. While the water is moving backward, what is the tendency of the wave? To sink. The tendency of the wave is to move down and backward. The water will move down and backward. No matter how much ever you try to come onto the coastline, continuously the water will get you back. Right? So look, this is how the water moves. And then they're collecting, they're coming in this direction. So see, this is a very lucid explanation I'm giving. In the further classes, in the mains classroom, I'll give you the technical words ke saath. The main agenda of this classroom is to give you a simplified understanding, ताकि आगे पढ़ने में मजा आए हमें, right? So what is this person doing? He's trying to swim against the riptide. So when you get to see a riptide, you'll definitely go into rip. ठीक है? What you have to do at that point of time? What does a smart person do if they are stuck in the riptide? Backward. One way is, if you are a good swimmer, you go along with the wave. This is one way. Other is swim the sideways. Okay? Instead of going against the water, the distance can be 300 to 400 meters. Now here, instead of going in this direction, आपको इधर जाके इधर जाना चाहिए, इधर जाके इधर जाना चाहिए. इंडिया में रिप वेव्स भी होता है, and this is मतलब locally they are found. Hardly they'll be found for half an hour, 1 hour, maybe 1.5 hours, then that will be gone. It is because of the direction of the wind also. Sometimes the wind comes and joins together, then it can be. Because of this, on an average, India mein riptide is one of the, the rip wave is one of the catastrophic wave, or the highest death causing wave on the east coast of India. So this is something in the current affairs. Recently, the blue flag certification ki regarding they were talking about. So I thought of taking this as an example to tell you in the part of the wave. Right. So a broad explanation of the waves is this. In the next class we'll meet. Okay? In the next class we'll be taking up few more topics. I have left the topic of cyclone. Okay? Next topic will take cyclones, both tropical cyclones and temperate cyclones. There is a popular demand from the students as well. We'll be taking up those topics. Right? Today is Friday and our next class will be on Monday. Right? Sir, does it also depends on shape of the coastline? Amit Khare, yes. It also depends on the shape of the coastline as well. So shape of the coastline, definitely it does. Look here. Just a minute. Shape of the coastline pe definitely it is, but dominantly this is because of the shape of the coastline. You have rocks that have set up. So the water that enters in, it has to go back, right? It can be shape of the coastline also, it can be because of the winds as well. So water is coming in and it is moving in the opposite direction here. So both the shape of the coastline and these factors also play a vital role, right? And lastly, see, the batch is going to start soon. If you are interested, you can enroll. The contact numbers are here. And if you want to interact with me directly, this is my contact number. And my name is Madhusudan Reddy. See you and thank you guys. Yes.